The laboratory is cold, dimly lit, filled with the sharp scent of chemicals. Glass beakers clutter the wooden tables, some filled with strange, glowing substances. In the center of it all stands a woman, her hands steady, her mind sharper than the instruments she wields. The weight of the unknown surrounds her, but she is undeterred. Every experiment, every measurement, every sleepless night brings her closer to uncovering a force hidden deep within matter itself. She is Marie Curie, a scientist, a pioneer, a woman who refused to accept the limits imposed on her. At a time when women were barred from higher education, denied opportunities in laboratories, and dismissed from the halls of academia, she fought her way in, not for recognition, not for glory, but for the pursuit of truth. Against relentless skepticism, institutional barriers, and even the dangers of her own discoveries, she pressed forward, guided by an unshakable belief that science belonged to no one. It was meant to serve humanity. What she uncovered was no ordinary phenomenon. Radioactivity, a force so powerful it defied the laws of physics as they were known. It would revolutionize medicine, offering hope to the sick. It would illuminate the mysteries of the atom, paving the way for nuclear science. It would change the very fabric of human civilization. But such knowledge did not come without sacrifice. The very element she dedicated her life to studying, radium, emitted an invisible danger. The glowing substance that had made her famous would slowly, silently take its toll on her body. She would become a martyr to science, unknowingly pushing past the boundaries of human endurance in her relentless pursuit of discovery. This is not just the story of a scientific breakthrough. It is the story of perseverance, defiance, and sacrifice. It is the story of a woman whose name is not only written in history, but in the very elements of the universe itself. This is Marie Curie, the woman who glowed in the dark, and this is how she changed the world. Maria Skłodowska was born on November 7, 1867, in Warsaw, Poland, then part of the Russian Empire. The youngest of 5 children, she grew up in an environment deeply rooted in education and intellectual curiosity. Her father, Władysław Skłodowski, was a physics and mathematics teacher, and her mother, Bronisława, managed a respected boarding school for girls. From an early age, Maria was surrounded by books, scientific instruments, and lively discussions on academic topics, an upbringing that would profoundly shape her future. Despite her keen intellect, Maria's childhood was marked by adversity. Poland was under strict Russian rule, and educational opportunities for girls, especially those from Polish families, were limited. Her mother's strict discipline and early loss to tuberculosis in 1878, followed shortly by the death of her eldest sister, left a lasting emotional scar. Yet these hardships only reinforced Maria's resilience and determination to pursue knowledge. From a young age, she exhibited exceptional academic abilities, particularly in mathematics and physics. She attended a clandestine educational institution known as the Flying University, which provided higher education to women in defiance of Russian restrictions. There, she was introduced to the world of scientific thought and inquiry, igniting a passion that would drive her lifelong pursuit of discovery. Though she longed for formal university education, financial constraints and societal barriers stood in her way. Maria made a pact with her sister, Bronisława. Maria would work as a governess to support her sister's medical studies in Paris, and in return, Bronisława would later help fund Maria's own education. It was a bold, calculated sacrifice, one that underscored her unyielding commitment to science and her unwavering belief in the power of education to change lives. As Maria embarked on this arduous journey, she had no idea that she would one day revolutionize the scientific world. Maria Skłodowska's unwavering dedication to education led her to Paris in 1891, where she enrolled at the prestigious Sorbonne. At the age of 24, she officially became Marie, adapting her name to fit her new surroundings. The transition was anything but easy. She arrived in France with little money, barely fluent in French, and wholly unprepared for the rigors of university life. Yet, her determination outweighed every obstacle. At the Sorbonne, Marie immersed herself in mathematics, physics, and chemistry, often studying late into the night in her unheated attic room. She lived frugally, sometimes surviving on just bread and tea, but academic excellence remained her priority. Despite the hardships, she quickly distinguished herself, earning her degree in physics in 1893 as the top student in her class. A year later, she completed a second degree in mathematics, finishing second in her cohort. During this period, Marie sought work to support herself, taking on research funded by industrial and academic institutions. She was particularly interested in magnetism and began working under the guidance of physicist Gabriel Lippmann. However, her career took a defining turn when she was introduced to Pierre Curie, a respected physicist whose work on crystallography and magnetism had already earned him recognition. Marie and Pierre shared not only scientific interests, but also a profound mutual respect. Their intellectual connection soon evolved into a personal bond, and by 1895, they were married. Instead of a traditional wedding, they celebrated with a simple ceremony, choosing to invest in bicycles rather than lavish gifts, symbolic of their shared passion for a simple life devoted to science. With her academic foundation solidified and a formidable partnership with Pierre, Marie was poised to embark on the groundbreaking research that would change the course of physics and chemistry forever. After her marriage to Pierre Curie in 1895, Marie Curie set out to establish herself in the world of scientific research. Though she had proven her academic brilliance at the Sorbonne, opportunities for women in science remained scarce. Determined to carve her own path, she sought a research topic for her doctoral thesis, one that would not only advance her career, but also contribute meaningfully to the field of physics. Marie became fascinated by the work of Henri Becquerel, who had recently discovered that uranium salts emitted an unknown form of energy. Inspired by his findings, she chose to investigate this mysterious radiation, a decision that would lead to one of the most significant discoveries in scientific history. However, she faced an immediate challenge. She lacked a proper laboratory. With no independent research position or funding, she improvised, conducting experiments in a cramped, poorly ventilated shed at the School of Physics and Chemistry in Paris, where Pierre worked. Despite these limitations, Marie demonstrated remarkable ingenuity. She meticulously measured radiation levels emitted by different uranium compounds, using an electrometer originally designed by Pierre and his brother Jacques. Her results revealed something astonishing. The intensity of the radiation was proportional to the amount of uranium present, suggesting that the phenomenon was intrinsic to the element itself and not a result of external chemical reactions. This realization was groundbreaking. It hinted at a fundamental property of matter previously unknown to science. Marie soon expanded her research to other elements and found that thorium also emitted similar radiation. She coined the term radioactivity to describe this new and unexplored force of nature. Her early findings, published in 1898, began to draw attention. But as a woman in a male-dominated field, she still had to fight for recognition. Yet, undeterred by the skepticism of her peers and the physical toll of her relentless work, she pressed forward, unaware that she was on the brink of a discovery that would alter the scientific landscape forever. By 1898, Marie Curie's meticulous research on uranium and thorium had already demonstrated that radioactivity was an intrinsic property of certain elements. However, her most groundbreaking work was yet to come. She suspected that some minerals, particularly pitchblende, a type of uranium ore, emitted more radiation than uranium alone could explain. This suggested the presence of unknown, highly radioactive elements. Working tirelessly alongside Pierre, Marie began processing massive quantities of pitchblende, systematically isolating its components and measuring their radioactivity. The tedious process was grueling. She handled tons of the mineral, often stirring boiling solutions for hours in an unventilated workspace. Yet, her perseverance paid off. In July 1898, the Curies announced the discovery of a new element, polonium, named in honor of Marie's homeland, Poland, which was still under foreign rule. But their research didn't stop there. as they continued. To analyze pitchblende, they realized it contained another, even more radioactive substance. By December 1898, they had identified a second new element: radium. Unlike any substance known at the time, radium emitted an extraordinary amount of energy, seemingly defying the laws of conservation as understood then. This discovery sent shockwaves through the scientific community. Not only had Marie and Pierre expanded the periodic table, but they had also introduced the revolutionary concept that atoms were not indivisible, as previously believed, but contained untapped sources of energy. Their findings laid the foundation for future atomic research, challenging fundamental assumptions in physics and chemistry. Despite the growing recognition of their work, Marie and Pierre faced an uphill battle to isolate pure radium, as the element was present in vanishingly small quantities. Extracting just a fraction of a gram required years of effort. But they remained undeterred, fully aware that they were uncovering forces that could reshape humanity's understanding of nature. Marie's pioneering research was no longer just an academic pursuit. It was ushering in a new era of science. Marie and Pierre Curie's discovery of polonium and radium in 1898 was only the beginning of their revolutionary contributions to science. The challenge now was to extract pure radium and understand its extraordinary properties. Over the next several years, Marie worked tirelessly in makeshift laboratories, refining tons of pitchblende to obtain minuscule amounts of radium chloride. The process required immense patience and physical endurance. She performed thousands of crystallizations by hand, exposing herself to unknown dangers. As their work progressed, the Curies made a groundbreaking observation. Radium continuously emitted heat and light, seemingly generating energy without diminishing in mass. This phenomenon contradicted classical physics, suggesting that atoms were not immutable, but capable of releasing immense amounts of energy, a concept that would later lead to nuclear physics. Marie's insight into radioactive decay would become one of the most profound scientific revelations of the 20th century. Their discoveries also had immediate applications. The intense radiation emitted by radium was found to destroy diseased cells, leading to early forms of cancer treatment. This medical potential made radium highly sought after, and the Curies, despite their financial struggles, refused to patent their discoveries, believing that science should serve humanity rather than personal gain. In 1902, after years of relentless effort, Marie successfully isolated 1/10 of a gram of pure radium chloride, proving beyond doubt the existence of this new element. The scientific world was in awe. Marie had not only expanded the periodic table, but had also pioneered a new field of research: radioactivity, a term she had coined. Her work challenged fundamental ideas in physics and chemistry, inspiring a new generation of scientists to explore the atom's mysteries. Yet, despite these remarkable achievements, Marie still had to fight for recognition in a male-dominated scientific establishment. The ultimate acknowledgement of her contributions, however, was just around the corner. Marie Curie's relentless dedication to science did not go unnoticed. In 1903, she and Pierre Curie, along with Henri Becquerel, were awarded the Nobel Prize in Physics for their pioneering work on radioactivity. With this honor, Marie became the first woman to ever receive a Nobel Prize, a groundbreaking achievement in a field where women were often excluded. However, even this recognition was not without challenges. Initially, the Nobel Committee intended to award the prize only to Pierre and Becquerel, but Pierre insisted that Marie's contributions were equally essential. Thanks to his intervention, her name was rightfully included. Despite this historic moment, Marie remained focused on her research. She and Pierre continued their investigations into the properties of radium, fascinated by its mysterious ability to emit energy without an apparent source. Scientists around the world took notice, and demand for radium skyrocketed, particularly for its potential medical applications. However, the Curies' lives took a tragic turn in 1906 when Pierre was fatally struck by a horse-drawn carriage. His sudden death left Marie devastated, but she channeled her grief into her work. Later that year, she was appointed to Pierre's professorship at the Sorbonne, making history once again as the first female professor at the university. Though many doubted her ability to lead in such a prestigious role, she quickly proved them wrong, delivering lectures with the same rigor and brilliance that had defined her research. In 1911, Marie received her second Nobel Prize, this time in chemistry, for her discovery of radium and polonium, as well as her work in isolating pure radium. This made her the first person ever to win 2 Nobel Prizes, a distinction that remains rare to this day. Despite this unprecedented achievement, she continued to face skepticism and criticism, especially as a woman working in science. Marie Curie's impact was not confined to the laboratory. Her discoveries were already shaping the future of medicine and physics. Yet even as she achieved global recognition, she remained devoted to her research, unaware of the personal cost that prolonged exposure to radiation would soon exact. Despite her historic achievements, Marie Curie's journey was fraught with adversity. As the first woman to win a Nobel Prize, and later the first to win 2, she faced relentless scrutiny from both the scientific community and the public. The early 20th century was an era in which women were rarely accepted as leaders in academia, and many of her peers were reluctant to acknowledge her accomplishments. Following her second Nobel Prize in 1911, Marie became the target of a harsh media scandal. She had developed a close relationship with physicist Paul Langevin, a former student of Pierre and a married man separated from his wife. The affair was sensationalized by the press, leading to public attacks that overshadowed her scientific work. The scandal reached its peak when an angry mob gathered outside her home, forcing Marie and her daughters to seek refuge with friends. Despite this turmoil, she refused to let personal attacks deter her. She attended the first Solvay conference in 1911, where she stood among the greatest minds of physics, including Albert Einstein, Max Planck, and Ernest Rutherford. Einstein himself, recognizing her brilliance and resilience, encouraged her to ignore the press and focus on her work. At the same time, Marie faced another obstacle: her health. Years of exposure to radioactive materials began to take their toll, though the dangers of radiation were not yet fully understood. She experienced chronic fatigue, anemia, and deteriorating eyesight. Yet she continued her research undeterred. In 1914, with the outbreak of World War I, Marie put aside personal and professional challenges to contribute to the war effort. She developed mobile X-ray units, known as Little Curies, and personally traveled to the front lines to assist battlefield surgeons. Her efforts saved countless lives, demonstrating that her devotion to science extended beyond the laboratory. Despite the prejudices, scandals, and physical toll, Marie Curie remained steadfast. Her perseverance in the face of adversity only solidified her place as one of the most influential scientists in history. As the 1920s unfolded, Marie Curie's influence in science remained profound. Despite deteriorating health, she continued her research, promoted the use of radioactivity in medicine, and traveled extensively to advocate for scientific advancements. She played a crucial role in establishing the Radium Institute, now the Curie Institute, in Paris in 1914, dedicated to studying radioactivity and its medical applications. This institution would become a leading center for cancer treatment and research. Marie also worked tirelessly to secure funding for her research. In 1921, she embarked on a highly publicized trip to the United States, where she was welcomed as a scientific hero. President Warren G. Harding personally presented her with a gram of radium, purchased through a nationwide fundraising campaign led by American journalist Marie Maloney. The trip not only provided vital resources for her work, but also solidified her status as an international icon of science and perseverance. Despite her continued dedication, years of unprotected exposure to radioactive substances had taken a devastating toll. By the late 1920s, Marie suffered from chronic fatigue, cataracts, and a severe form of anemia. Physicians struggled to diagnose her condition, as the effects of radiation poisoning were not yet fully understood. Nevertheless, she remained committed to her work, guiding young scientists at the Radium Institute and ensuring that her legacy would extend beyond her lifetime. Marie's final years were marked by both personal and professional reflection. She recognized the immense potential of radioactivity, but also the risks associated with its uncontrolled use. Though she never lived to see the full consequences of nuclear energy, her discoveries paved the way for both groundbreaking medical treatments and, later, the development of nuclear power and weaponry. On July 4, 1934, Marie Curie passed away at the age of 66 from complications related to prolonged radiation exposure. Her death marked the end of an era, but her work would continue to shape the scientific world for generations to come. Marie Curie's journey was not just one of scientific discovery, it was a testament to resilience, sacrifice, and an unyielding pursuit of knowledge. Marie Curie's groundbreaking discoveries in radioactivity reshaped the fields of physics, chemistry, and medicine, leaving an enduring scientific legacy. Her work laid the foundation for modern nuclear physics, influencing generations of researchers and leading to technological advancements that transformed the world. One of the most significant impacts of her discoveries was in medicine. Radium's ability to emit powerful radiation led to the development of radiotherapy, a revolutionary treatment for cancer. The Curie Institute, which she helped establish, became a pioneering center for cancer research and remains one of the most respected institutions in the field. Today, radiation therapy remains a cornerstone of oncology, saving countless lives worldwide. Beyond medicine, Marie's discoveries contributed to the development of nuclear energy. Although she did not live to see the full realization of atomic power, her work inspired the scientists who later harnessed nuclear fission for energy production. However, this same knowledge also led to the creation of nuclear weapons, a controversial consequence of radioactivity's immense potential. Marie's influence extended into education and scientific institutions. The Radium Institute in Paris and the Curie Institute in Warsaw, both established with her guidance, became leading research centers. Her daughter, Irène Joliot-Curie, followed in her footsteps, further advancing nuclear science and earning her own Nobel Prize in chemistry, alongside her husband, Frédéric Joliot-Curie, for their discovery of artificial radioactivity. Her contributions were also recognized in a unique and lasting way. In 1944, the element curium, Cm, was named in honor of Marie and Pierre Curie, ensuring their names would be forever embedded in the periodic table. Marie Curie's legacy is not just scientific, but symbolic. She shattered gender barriers, proving that intellectual brilliance knows no boundaries. She was a pioneer who changed the course of history, and her work continues to influence the world in ways she could never have imagined. Nearly a century after her passing, Marie Curie's legacy remains as influential as ever. Her discoveries in radioactivity continue to shape modern science, medicine, and technology, proving that her contributions were not confined to her own, but have had far-reaching consequences that endure to this day. In medicine, the field of radiotherapy, which originated from her research, has advanced significantly, offering highly effective treatments for cancer and other diseases. Innovations, such as proton therapy and targeted radiation treatments, are direct extensions of the work she pioneered. Hospitals and research centers worldwide continue to use radioactive isotopes in diagnostics and treatments, a testament to the enduring value of her discoveries. In nuclear physics, Marie Curie's work laid the foundation for the study of atomic structure, leading to the development of quantum mechanics and nuclear energy. Although the rise of nuclear power and weapons brought ethical dilemmas, her research enabled humanity to tap into one of nature's most powerful forces. Today, nuclear energy plays a critical role in addressing global energy needs, offering a cleaner alternative to fossil fuels. Marie Curie's legacy is also deeply woven into the advancement of women in science. She remains a symbol of perseverance, intellect, and resilience, inspiring countless women to pursue careers in STEM fields. Institutions, awards, and scholarships bear her name, dedicated to fostering the next generation of scientists. The Marie Curie Actions Program, established by the European Union, supports research and innovation by funding young scientists worldwide. Her contributions are recognized beyond academia. In 1995, She became the first woman to be interred in the Pantheon, in Paris, on her own merits, resting among France's greatest figures. Her name is immortalized not only in scientific texts, but also in culture, with countless books, films, and documentaries celebrating her extraordinary life. Marie Curie was more than a scientist. She was a visionary whose work transformed the world. Her story is a reminder that curiosity, perseverance, and dedication to knowledge can break barriers and redefine what is possible. As science continues to evolve, her legacy stands as a beacon, guiding future generations toward discovery and innovation.